welcome to another video. This one talks about the segment relationships in circles. The first relationship is the chord-chord theorem. This is two chords that will be separated into pieces by the point of intersection. So in this case, I have chord A, E, and chord D, B, or BD, and they intersect at point C. The formula is AC multiplied by CE is equal to BC multiplied by DC. Alright, so really it's the two pieces of the chord multiplied together is equal to the other two chord pieces multiplied together. So let's look at an example. And for the examples, usually you would have to solve for x. So let's say I'm going to put in some figures. So I have 7 here. Let's use a different color. So I have 7 here. I have 10. I have x for AC. And finally, CE is equal to 14. So AC, which is x, multiplied by CE, which is 14, is equal to BC, which is 10, multiplied by DC, which is 7. So we have 14x equals 70. And then we divide both sides by 14. Therefore, x is equal to 5. Alright, we can go a step further and find the total length of each one. So let me just erase what I have here, and let's say we need to find the length of each chord. So for A, E, that will be equal to 5, which we found, plus 14, and that's 19. And BD is equal to 7 plus 10, which is 17. So note that the length of the chord can be different, but when we multiply each piece, then they should give us the same value. Okay, let's look at the other theorem. This one is the secant-secant theorem, and as the name suggests, you have two secants. All right, so remember the secant touches the circle two places, but it extends beyond the circle. With the chord, it remains in the circle. So what is the rule that governs the theorem? Governs the secant-secant theorem. All right, so for the secant-secant theorem, it goes like this. AC times AB is equal to AD times AE. In other words, we have the whole line multiplied by the outside is equal to the whole times the outside. All right, so my whole is AC, and I'm going to multiply it by what AB is, and then the whole on the other side is AD multiplied by AE. All right, let's look at an example. If we have this here 8, we have x, we have 7, and we have 9, and we need to solve for x. How will we go about doing this? So the whole is 8 and x, so it will be 8 plus x, that's the whole, multiplied by the outside, which is 8, is equal to my whole, which is 7 plus 9, and that gives me 16 times the outside, which is 7. Yeah, so let's distribute and solve. So 16 times 7, that's 112. And then I'm going to do 8 times 8 and 8 times x. So I have 64 plus 8x. And then we solve for x. We subtract 64, subtract 64. That will cancel. So I'm left with 8x equals 112 subtract 64, that's 48. And then I divide both sides by 8. So x is equal to 6. Alright. Again, we can find the length of AC. So AC, let's just use a different ink. AC is equal to 8 plus 6. And that gives us 14. Alright, let's look at the last theorem. So the last theorem is the tangent-secant theorem. So my line AB is a tangent because it touches my circle at one place, the point of tangency being point B. And then my secant, which is AC. So the theorem says that your tangent line, you're going to square that. So whatever AB is, we're going to square that, equals the whole line, which is AC, times the outside, which is AD. So it's similar to what we did above. AB squared is equal to the whole times the outside. Let's look at an example. So AB is x, and we have here being 5 and in here being 15, and we need to solve for x. So don't forget AB, the tangent is always squared, so that means I have x squared equals the whole, which is 5 plus 15, that's 20, multiplied by the outside, which is 5. And then you solve from there. 20 times 5, that's 100. And then we need to take the square root of 100. So that would be plus or minus 10. But because we're dealing with length, we're going to use the positive number. So x is equal to 10. And there you have it.